Hello and welcome to this video on why pH changes can cause your bonsai flowers to change colour. Different bonsai prefer different kinds of soil. One of the better known examples is azaleas. These small flowering shrubs, come bonsai, prefer a slightly acidic soil. Using a good azalea soil will lead to better plant growth and flowering. Less well noted in bonsai circles are hydrangeas. These are plants that turn a reddish pink in basic soil and a bright blue in acidic soil. The question now is how the soil causes these changes. For the purposes of this video, we're going to try and focus on hydrangeas as an example species, but there are outliers and exceptions we will mention. At the very simplest, a small change to the molecular structure of your soil can change the molecules within the flower itself, specifically the flower pigments. It is the pH change that alters these structures, and it's because the pH can change the electrical charge of the molecules responsible for it. Because they're differently charged, they can bind themselves in different ways. These different configurations, let's say, lead to different interactions with light, and it means the light we observe either bouncing off or being absorbed by these particular compounds or chemicals is a different colour. This is essentially the same way that an indicator would work. As a practical example, you can use hydrangeas, and these flowers will turn blue in an acidic soil that is 5.5 or lower on the pH scale. If the flowers are above 7, they will be a pinkish colour. Anywhere between 5.5 and 7, there'll be some sort of shade in between pink and blue, effectively a purple-like colour. What we see when this happens is the effect of pH playing out on the molecules and particularly the pigments within the flower itself. Now, what these pigments are can vary drastically from species to species. So the first we can speak of here is cyanidins and pelargonidin derivatives. And yes, both of these are as hard to write as they are to pronounce. This is found by extracting them from a flower called dubium. Ironically enough, the dubium flower is not very dubious, as it is a real thing. However, once you extract these particular molecules and put them in a pH below 5, you'll find that they change their structure, and particularly one of the extracted compounds under this category is the flavulum compound. When you have this in the right environment and you have cations, it becomes a colorless compound, and so you don't see it. This is done by hemiketal and cis and trans calcone forms. When you have a higher pH, the quinoidal bases are created. That is effectively the opposite. This means you have two possible directions and two possible formations that can be generated from it. This is particularly useful if you're trying to understand what's changing, in that particular example, however. Then there are the flavonols themselves, and again, this is all based on pH changes. You'll find that they basically become red. These flowers become red when you use an acidic mixture, and that affects the anthocyanin content. You also have more flavonoids on top of these we've mentioned already. The anthocyanins are particularly important. When you combine either anthocyanins and cyanin glycosides, they can vary drastically, and these are one of the compounds that could be responsible, and in some cases are responsible for hydrangea changes. They go from a pink colour to red, purple, and then blue. This is from a pH of 3.1 to 5.5. What changes with these is that you have anthocyanins, and when you expose them to low pH values, they change form, and as a result, you get a diminishing absorption of the light, particularly the blue light range, so more of that bounces off the molecule and that's what you see. You don't need huge changes shifting from, say, 3.5 to 7. It can be much smaller, say from 3.3 to 4. This occurs in the hydrangea specifically, but within the macrophylla. This is why you get the blue to red transition. A general rule for this is that the color change occurs as a result of the macrophylla sepals, that is part of the flower, shifting their color, And again, this is all down to configuration and the way a light hits it and bounces off. You can also see the same thing in morning glory. Different kind of morning glory to what you might be thinking of. This also involves changes in something other than compounds within the flower itself. In this case, it's vacuoles. When you get from a pH of 6.6 to 7.7, you get the anthocyanin within these vacuoles, and specifically, the triaffiliated anthocyanin. This leads to the blue coloring, and again, it's owing to the change in structure. It's the anthocyanin and flavanol-based colors more broadly that do it, but all these are found within the vacuola rather than within the petals themselves, so to say. This is all information you can use a number of ways. The simplest is if you have a pH test kit suited to soil. Test your soil and make adjustments to achieve the desired color by shifting pH until you reach the right range. Just remember, it can take time for a change in pH to occur, and being impatient may overshoot your target by a long way, and it is in some respects harder to undo the changes than it is to make them happen. In other cases, it can help to be aware that some species may rely on the plant vascular system and not isolated compounds. This means more vascular plants will show more coloration, while those less vascularized will not, for a time at least. And this is simply because the plant will gradually adjust, whereas if you have particular compounds or flavanols and similar within the petals, they will change color and they will stay changed as long as the environment remains at the right pH for it. You don't alter their configuration whatsoever, whereas vascular changes and vacuoles may. As you can see, it is more than just adding an acid or a base to your soil that changes the color of flowers. It is even true in some cases it is not the flowers so much that change, as it is the plant equivalent of arteries and veins, known as xylem and phlegm. Being able to work with this and get the most out of your species can be incredibly helpful if you want a better display, particularly if you only want to change the soil conditions temporarily. Thank you for watching this. If you found it interesting, consider liking, sharing, and subscribing. Please post any comments, questions, or suggestions you have below.